this video, we're going to continue talking about random variables and probability distributions, specifically talking about checking for normality and normalizing transformations, specifically the normal probability plots. A normal probability plot is a tool to help determine whether a population is normally distributed. So we're going to plot normal scores against the observations. A strong linear pattern suggests that population normality is plausible. So some example normal scores. There are many ways to calculate these, and these are calculated with the formula f sub I equals I minus 0.5 divided by n, where I is the position of the observation and n is the total number of observations. These are probabilities that we then find the z-scores of. Now these z-scores are the normal scores. So notice here that we have when we have 5 points, the scores when we have 10 points, and the scores when we have 20 points. So we're going to do an example where we're going to have 10 points of data. So we're going to be using these normal scores here against our values. Let's take a look at that now. Given the weight of 10 eggs, call that G, determine if the weight are normally distributed. So here we have our 10 values right here, and we're going to graph those against the normal scores that we saw on that previous slide. When we graph those, we see that they look relatively normal. When we calculate their linear regression and their coefficient of determination, we have an R-squared value of 0.9731, which shows us that there's a strong linear correlation, telling us that it's very likely that these eggs are normally distributed. So this is something that you can do by, again, using the formula from the last page and then entering these into your calculator in the stat plot, and then finding the linear regression and making sure that your coefficient of determination is on as well. So again, if you can calculate the normal scores, and again you can use the formula from earlier, then you can calculate the R-squared value of the normal scores to observations, thus allowing you to know if in fact those scores, those observations, can be considered normal.